these key features for trigonometric functions and going back and forth from like graph to an equation or description to an equation. But we're going to add in a new wrinkle, and we're going to start talking about what happens if we have some shift going on that has moved our graph left or right, some kind of horizontal shift. We're going to include how we deal with that. Everybody good with that plan? Okay. So let's start with, well, I guess last time I gave you guys some delta maths to work on, right? That went okay. Hopefully that was reasonably easy. I think the questions were pretty straightforward given what we asked you guys, or what I explained in the lesson. Should have been okay. So let's take a look here at this first picture. And let's try to write the equation for this one, okay? So the first thing we want to do is we want to locate the midline. Who can see where that midline is? Edie. Yeah, it looks like right here is that midline, right? Dividing it in half vertically. And which of our constants does that midline give us? A, C, H, or K? K. What is the K then? Just -1. Nothing to do there, right? All right. Who can tell me the amplitude? What was that? I heard 2. Thanks, Paige. Yeah, so if we look at the distance from the midline to any extrema, so we start at -1 and we end at +1. So that tells us our amplitude is 2, which tells us about which constant, A, C, or H. Do you remember? A is correct. So if the amplitude is 2, the A has to be, or -2. We don't know which one yet, so we'll just write plus or minus there. We'll make a decision here in a few minutes about which one we should use. Everybody's okay there? Okay. And the last one we want to talk about is the period. Who can tell me the period? Edie. Pi is correct. So I like to usually start at x equals 0, so touching the y-axis. And if I return back to that minimum position, that's one cycle of my function. If I look at that horizontal distance from start to finish of that cycle, started at 0, ended at pi. So the period is pi. Does everybody feel okay on how we did that? Again, mostly we're just using our eyeballs, right? We're not doing anything complicated. Does it matter like where I start and end my cycle at? No, I mean, I could have gone from like, I could have done that for my cycle. Or I could do, like that for my cycle. It doesn't really matter. I usually like to start my cycle at 0 just because it makes the arithmetic really trivial. I don't have to muck around with like doing a bunch of complicated subtraction, maybe running into a fraction. Oh my gosh. All right. So which coefficient does the period tell us about, C or H? C. And what is the relationship between the period and C? So the when we put the C into the formula, that's where the reciprocal comes in. But the period in C is not a reciprocal relationship. The period is equal to 2 pi times absolute value of C, right? Right, that's our formula. The period is equal to 2 pi times the absolute value of C. So if our period is pi, what did C have to be? Would I multiply 2 pi to get 1 pi? Would I have to multiply 2 pi by to get 1 pi?
Pi over 2.
1/2, right? Yeah, just 1 over 2. Is everybody okay with that? Again, if you wanted to divide both sides and like make a whole equation out of it, you're welcome to do that. If you need to do that, please do that. I think this is one where it's not unreasonable for us to look at and go, okay, C is 1/2 because 1/2 times 2 is 1, and the pi just hangs. But remember, there's that absolute value there, so it's not just 1/2, it's plus or minus 1/2, right? Is this all looking familiar, right? This is similar to what we did in one of the delta, or 2 of the delta maths. I think we looked at graphs and had to do this, right? Okay. Now, the last piece here, we want to put this together into an equation. And since we haven't made a decision about whether it's sine or cosine yet, I'm going to just write trig there, because we know we're going to put either sine or cosine there, but I don't know which one, and I don't want it to be confusing, so I'm just going to write trig in capital letters to represent one of the two. Do you remember how we decided which one we wanted to use? You want to look at what's going on with the graph at x equals 0. So at x equals 0, the graph is there. Bless you, bless you. Now, what type of point is that at x equals 0? Is that a minimum, is it a maximum, or is it a midline point? That's a minimum. Everybody can agree with that? So if I get a min or a max, that tells me the trig function I want is cosine. If I have a midline point, the trig function I want is sine. You guys know what I mean by a midline point? So like your midline points would be like any of these guys that are where the graph crosses the midline, right? Okay. So that tells us it's cosine. It also tells us another thing. Because it's at a minimum, it's going to tell us whether I want positive A or negative A. Which A do I want? Negative A, because it's a minimum. So because that point at x equals 0 is a minimum, it tells me I need to use cosine, and it tells me I need to use a negative value for A. So if we fill everything in then, we have negative 2 cosine of 1 over c. So I'm going to, what did I tell you to do for the c's always? Positive, right? Always going to just use positive. All right, so 1 over c is going to be the reciprocal of 1/2. What's the reciprocal of 1/2? 2. There's that 2. We have no h in this. So there's my equation. Now, the reason I know I can use no h, again, is because at x equals 0, I had either a midline point, a maximum, or a minimum. If one of those things is going on at 0, I don't need an h. The h is going to tell us the shift left or right. Everybody's okay with that idea? Okay. So, Mr. Kulik, when we introduced this idea, you gave us these, like, you showed us the picture of sine and cosine, and they were basically the same graph. They were just shifted left or right a little bit, one or the other, right? So shouldn't I still be able to write the equation for this example using sine if I just have a little shift going on? Yes. Yes, I can. Let's show you how to do that. Okay, so we're going to look at this exact same one here. And we're just going to do the same thing as a sine equation. So the a is still plus or minus 2, just like we found. The k is still negative 1, and the c is still plus or minus 1/2. That part stays the same. We would have done those same steps exactly as we had before. Nothing has changed there. There's my midline. So what I'm going to do now, if I want to do this as a sine, I'm going to choose for myself any midline point on my graph. It doesn't matter which one I choose. Any midline point will be fine. So let's say, for example, I picked this one. Everybody okay with that? So if I look at the x-axis, I see there's 1, 2, 3, and then the fourth tick point is pi, right? Going from 0 to pi. Everybody see that? So how far is that first tick mark in terms of pi? Well, it's 1/4 of pi, right? Everybody's okay with that? So that point is pi over 4. Let's get the thicker pen. Comma negative 1. This pi over 4 is just going to be our h. So if you're doing a sine function, the x-coordinate for the midline point that you choose can just be your h. So for choosing to do a sine function, the x-coordinate from your midline point can just be your h. It can be that simple. Does that feel okay? No big deal so far? Okay. What decision do we still need to make, though? Yeah, we still need to figure out if that a is positive or negative. So this is how we're going to do that. I'm going to look at the next extrema after the midline point I've chosen. That next extrema is a maximum, which tells me the a should be positive. If the next extrema was a minimum, we would say the a is negative, right? So we've already chosen to write a sine function, right? So we picked the midline point, and the extrema after that is going to tell us whether the a is positive or negative. Okay? So now we have everything we need. So negative 2 sine of, always picking that c to be positive. Our h is just pi over 4. And if you want, you could distribute the 2 through. You don't need to do that. You can just leave it in this factored form or whatever is fine. Is that okay? All right. So you saw in this previous, or in this example, when we write it as a cosine function, we didn't need an h. If we wanted to write it as a sine function, we did. Let's look at an example now where, regardless of which one you wanted to do, sine or cosine, you're still going to need h's for both, and how to deal with that. Sound good? Is the pace going okay? It's clear as to what we're doing? I'm trying to be slow and careful and really kind of explain things through. Okay. As long as you guys are happy. All right, let's look at this example then. We're going to start the exact same way regardless of what's going on. We're going to identify the midline point to get the k, find the amplitude to get the a, look at the period to get the c. Always starts that way no matter what is going on. Okay? Somebody new who hasn't participated yet, can you tell me where the midline is? 3. Very good. So it looks like there's our midline. So that's y equals 3. What's that tell me? The A, C, H, or K. K. And what is the K then? Just 3. Good. Okay. Somebody else knew. What's the amplitude going to be for this? Thanks, Kiara. She says 2 with a hand sign. So again, it can just be the distance from midline to an extrema. That's 2 units. And Kiara, does that tell me about A, C, or H? A. And what does the A have to be? Perfect. Thank you. So far, so good. All right. Let's do the period next. So if I look at this, if I try to start at x equals 0, I don't know that I'm going to be able to figure out where that is on the next one, right? Like, maybe, maybe not. I think it's going to be a little bit clearer if I just go like from like max to max or something. I feel much better about understanding where my period starts and ends, or my cycle starts and ends, if I go from max to max or min to min or midline to midline, rather than starting at x equals 0 where it's like I don't really know where that is on the graph. It's not one of those key distinguishable points. Do you guys see what I'm saying there? So what I need to do now is I need to identify the x coordinates for those 2 points, because unfortunately they don't end at a grid line. You guys see that? What I do notice is it looks like it's halfway in between 2 grid lines. I'm just going to use my eyeballs and assume that's what's going on. It'll always be something where it's like kind of obvious that, okay, if it's not on a grid line, it's halfway in between. So if I look over here, so I know each grid line, there's 1, 2, 3, 4 grid lines before I get to a whole pi. So each grid line is a quarter pi. Half of a grid line then is a eighth of pi. Half of a quarter is an eighth. You guys okay with that? So this point over here is like negative pi over 8, comma, what is that, 4. No, that's 5. Okay. And then this other point then is, let's see, we are 2/8, 4/8, 6/8, and then one more, so 7/8. Is everybody okay with how I counted that out? A quarter I counted as 2/8. So each grid line was 2/8, 2/8, 2/8, and then I had that one more eighth for the half. Is that okay? If it's not, if you're confused on the fractions, like stop me and ask. I know fractions can be scary. I'm trying to do it in like a really intuitive way where it's not like overly complicated though, where we're just kind of counting. Okay, so how far is it to go from negative 1/8 to positive 7/8? So you take the left end, or I'm sorry, the right end and subtract the left end. So 7/8 minus a negative 1/8 is 8/8, right? Or just 1. So 1 pi. Is everybody okay? Again, when I'm doing mostly the fraction arithmetics, I try to ignore the pi and just like stick it back on at the end because it doesn't, as long as I'm adding things in terms of pi, it doesn't really matter. You know what I'm saying? Okay. Well, that's something we've seen before. What's the C going to be if the period is pi? It's 1/2 again, right? It's the same problem we did before. Is everybody's okay? Right? We already saw that the period of 1/2 gives us C is plus or minus 1 in the previous problem, so I'm just stealing that work again since I've already solved that equation once. I don't want to do it again and again and again and again. Like once is enough. Thank you very much, sir. Okay. So I have my A, C, and K. What I'm going to do now is pick the type of trig function I'm going to write, either sine or cosine, and then pick the point off my function that I'm going to use to figure out the h. Okay, so let's say for cosine, I'm going to use blue, this light blue here, and for sine, I'm going to use this green. So far, so good? Okay, so for cosine, I'm going to pick a extreme point, a max or a min. It doesn't matter which one I choose. Any is going to be fine. Now, given what I've done so far, it would be silly to pick any point other than negative pi over 8 or 7 pi over 8, right? Because I've already identified what the x coordinate is. I don't have to do any additional work figuring that out. You guys cool with that choice, one or the other? But you don't have to. You could pick any extreme point on there, min or max, any one of them. It will be fine, but let's not do more work than we need to. So let's say we picked this one. What that's going to tell me then, since that's a maximum, it tells me the A is positive. And because the x coordinate is negative pi over 8, tells me that the h is just the x coordinate. And now that's everything I need. So we have y equals 2 cosine of the reciprocal of 1/2 x minus h plus k. Any questions on that? Feels okay? So next I'm going to pick, for sine, I'm going to pick a midline point. Any midline point is fine. Let's say I pick this one. What's the coordinate for that midline point there? I think Ava just walked into her class. Hey, ILOs. All right, so the x coordinate there looks like it's positive pi over 8, right? Or we're just like half of a tick mark, and then the y coordinate's 3 or whatever. Okay. So if I look at the next extrema after our midline point, that is a minimum. What does that tell me? A is negative, and the h needs to be the x coordinate from the midline point I chose. Now, to be clear, what I've written are two possible answers, right? How many actual answers do I have for cosine? I have infinitely many, right? Because how many extrema do I have that I could have chosen? Infinitely many, right? Because it keeps on going and going and going and going forever, right? Same thing with sine. There's infinitely many answers because I have infinitely many midline points, because the graph just keeps going and going and going and generating them. On a test or quiz setting, a correct answer is a correct answer. Doesn't have to be a specific one unless the directions say specifically like you have to use, this point that I've labeled on the graph for you to use. In which case then, okay, that should tell you like, okay, it means that I have to do sine or cosine depending on where that which point is given to me. And I have to use that as the h value because that's the point. But it's pretty easy. Does this feel okay? No big deal so far? Okay. The other situation I want to talk about is what if when giving a description, I specify that your answer has to have certain points, right? So like, let me give you an example here. We'll do a couple of these. We'll start with the easiest possible situation. So again, this is very similar to the last set of problems from the Delta Math, but instead of just telling you a description, we're also specifying that the graph has to pass through a specific point. In this case, it's the point 3, 1. So far, so good? Okay. So we'll still start the same way. So the amplitude of 4, that gives me what? What does that tell me about A, C, H, or K? Great. The A is plus or minus 4. The period of 3 pi, what is that going to tell me? It's what I'm going to use to find C. So to do that, I'm going to say 3 pi equals 2 pi times the absolute value of C. What do I need to do to both sides to solve this equation for c? Divide by 2 pi. So when I do that, the pi's cancel. So I have my c is plus or minus 3 over 2, but we always pick c to be positive. Again, you don't have to do that, but just take my word for it. It's like the simplest way of doing these is to just pick the c to be positive. Now, what two things do I still need? I still need h, and I still need k. The only thing I haven't used is this point. Does it tell me what kind of point 3, 1 has to be? It doesn't, right? It doesn't tell us that 3, 1 is a midline point or a maximum or a minimum or something else. You know what that means? I have the freedom to choose what kind of point that is. You can just decide. You can still get a correct answer no matter where you decide to put it on your function. But let me tell you what, you can make this problem really easy or really hard based on this choice. The easiest choice is to choose this to be a midline point. So I'm going to choose that to be a midline point. If I do that, it means that I'm going to use sine as my function. The h is going to be the x-coordinate, and the y is going to be the k-coordinate. If I make that choice, which is makes this pretty stinking easy, right? Well, could I show you how to do it if you didn't make that choice? Sure. Does anybody really want to see how this would be harder if you make a poor choice here? Or do you just want to be like, I'm just going to choose it to be a midline point and go on about my business because Mr. Kulik, that was pretty easy. I don't blame you if you say, let's just keep it simple. I don't need to see what would happen if this is hard. What one decision haven't we made yet? Yeah, the plus or minus on the a. Does a being positive or negative affect where that midline point is? It's not going to. So guess what? Both choices are correct. If you choose sine, the sign on a doesn't matter. If we're going to make a sine function, and we're choosing this to be a midline point, and it doesn't specify anything about like what's happening before or after that midline point, it doesn't matter. So I'm just going to pick it to be positive. So I have a times sine, and then I'll do 1 over c, so the reciprocal of c, don't forget to do that, x minus h plus k. Okay. I just want to illustrate to you visually. So here's the point 3, 1. That's that spot in white. If I graph y equals 4 sine of 2/3 x minus 3 plus 1, goes right through it. Or if I had made that negative, still goes right through it, right? Both the blue graph and the yellow graph have the same amplitudes, the same periods, and pass through that point. They're both correct answers, even though they're not the same graph. They meet the specifications that I'm given, even though they're different graphs, right? Is everybody cool? As to why that A didn't matter, whether it was positive or negative. I think that really helps to just see it. It's like, oh yeah, sure, still works. Okay. What do you guys think? So far, so good? Okay. Next one. So in the previous example, we saw that if we didn't specify what kind of point our graph needs to pass through, we're just going to choose to make it a midline point, so we use a sine function. Here, though, we're specified. We have a minimum at 510 and a maximum at 1532. Here we've told you that those are what the points have to be. So there's no choosing anything else, right? And in fact, we're told that we have this minimum, and then the next maximum after it is this one. There's not another maximum in between or something, right? Is everybody okay? So when I see one of these descriptions and it deals with only mins and maxes, I'm going to choose to use cosine. Okay? If I have mins and maxes only, I'm going to choose to use cosine. If I have midline points or unspecified points, I'm going to choose to use sine. Everybody is okay with that? Okay. I want to show you now some justification for what I'm about to say. So I'm going to go back and look at this previous example. So if I look at the minimum and the maximum, where's the midline point located? Or the midline located? Halfway in between, right? Everybody agree with that? And what is the amplitude again? If I look at this distance from min to max, the amplitude is half of that distance, right? So that's what I'm going to use those two observations now to figure out the midline point and the amplitude. I just want to justify what I'm about to do. Okay? So my K, my midline point, or my midline, is going to be the average of the y coordinates. So that's a formula that you're free to use. So far, so good. My amplitude is going to be half the distance. So that's going to be subtraction. So the amplitude is 11, so the A is plus or minus 11. So far, so good. Okay. What I'm going to do next is try to figure out the period. To justify what I'm about to do, I'm going to sketch a little picture of what I know so far. Is everybody okay with this? So we have our minimum down here at 510. we have our maximum up here at 15, comma 32. And if I were to extend this so that I have one complete cycle, it would look like that, right? Or that would be the end of my full cycle. Everybody agree? Does that picture feel okay? How much of my cycle is that part from the min to a max? How much of the cycle? A half. Does everybody see that with their eyeballs? Can see that? Oh, that's just half the cycle. So that means that the distance from the maximum's x-coordinate to the minimum's x-coordinate is half a period. And I'm going to, when I write this formula, I'm going to just put an absolute value around it, because I don't know in the future, if I was doing this, what if it gave you the maximum value first with the smaller x and the minimum value second with the bigger x? If I just slap an absolute value around it, because it's a distance, so it always needs to be positive, then I don't have to muck around with like, oh, but sometimes it might be x min minus x max. It depends on like x on the left versus, the subscripts get annoying. I'm just going to slap an absolute value around it and just subtract the two x's, and that's going to be good. Okay, so I know then that one period is going to be 2 times that, right? So I knew that a period is 2 pi times c. So my c is going to be 20 divided by 2 pi. Oh my, yeah. Or 10 over pi. And we always choose the positive version. So there's my c. Now, when you are given 2 points like this and just 2 points, we're always going to have to draw this little picture, because the picture is going to tell me how much of a period I have, right? That's always going to, I'm always going to need to do that. It'll always be like a quarter or a half or 3 halves or something like that, right? It'll always be some kind of fraction of 4 with denominator 4, but everybody's cool? Okay. So I have plus or minus a. I have almost my a. I have my c. I have my k. What am I still missing? H. Here's the good news. H is really easy. Remember when we did this before with the graph, when I did cosine, I had to pick a max or min point, right? Do I know any max or mins? Yeah, totally do. I was given 2 of them in the problem, right? So guess what? I'm just going to pick one of them. So let's say we pick this one. That tells me the H is 5. And because it's a minimum, it tells me that the A is negative. If I had chosen the other point, you also get a correct answer. It would just tell you that the H would be 15 and the A would be positive because it's a maximum. Everybody feel good there? All right. Now we got everything we need, so we can just put it together. So y equals negative 11 cosine the reciprocal of c, x minus h plus k. Or if you had used the other point, you would have said 11 cosine pi over 10 x minus 15 plus 21. That would also be a correct answer. And just to illustrate this for us, let's get rid of these guys. We had 5, 10, and then 15, 32. I'm going to have to zoom this out in a minute. Okay. And then y equals negative 11 cosine pi over 10 x minus 5 plus 21. Notice that goes through. Or the other answer we could have done would have been positive 11 and then x minus 15. Notice that's the exact same picture, right? Still works. Is everybody cool? This is basically as hard as it gets, is this kind of problem right here. So notice that finding that h turns out to be pretty easy if we choose which function we want to use based on the information we're given, right? So if I have midline points or a free point, I choose sine, and then h is just the x-coordinate. If I have mins and maxes, I choose cosine. Again, the h is just an x-coordinate. It's pretty easy. As long as you're choosing things that way. And you have a lot of freedom to choose to get the correct answer, right? So in the case of something like example 4, where it just says construct the sinusoid, it doesn't matter whether you write your answer as a sine or a cosine, but because you're given maxes and mins, you'd be crazy not to pick cosines. It's much harder if you pick sine to do there. You can take my word for it. I won't show you what you'd have to do to get it, but you can just take my word for it. I hope you believe me. What do you guys think? It's okay? All right. So your homework, what we're going to work on today is going to be worksheets 5. I'd like you to start with worksheet 5 and then worksheet 4. So in worksheet 5, we give you the graph. I've plotted and labeled individual points on there. It's hard to read that I'm zoomed in, but this is like 3 pi over 2 comma 3 pi comma 1 pi over 2 comma negative 1. So I'm asking you, when you write your answer, that you'll use one of these 3 points to do it. Doesn't matter which one. Write your answer using sine, and then write your answer using cosine. Ask you to actually write both possible answers. Why would we get 2 possible answers for cosine here? One answer could use the minimum. The other answer could use the maximum. And then I have another one here, same story. That's it. That's it for worksheet 5. Worksheet 4 are just like these examples that we just got done doing. So I'll give you a description and we'll specify a point that it has to go through. I don't want you guys to do number 3. Okay? Don't do number 3. In fact, I'll put an X through it. Because it's asking you to do it the hard way. Like, here's a free point and write a cosine version. I don't want you to do it. Okay? And etc. So there's 6 problems total on this one. Everybody feel okay about what we're doing next? This will be part of Sunday's problem set. We can take the remaining 30 minutes or so of class to work on this to get started. I highly recommend you take advantage of this time to get started, because if you run into questions or you're not sure on something, you can get immediate feedback, and boy, that's helpful in getting the homework done if you're able to get like, okay, I think I got to start on this. I know what I'm doing. I had tried some stuff on my own. I had to ask some questions, and I feel much better about it leaving the room now. Okay?
Wait, are these due this Sunday?
This will be part of Sunday's problem set, so this Sunday, because we meet again on Thursday, so you can ask questions. So it'll be part of, this will be all of Sunday's problem set, in addition to the Delta Math I assigned last Friday, but you probably finished that already, because I don't think it was too hard to do. Yes.